All right, let's get a move on. So what I'll do is just pick a group, and I'm going to have you tell me what you got the direction to be. We'll talk about it. We'll see if it's right. And you guys just follow along as we go. If you need to change any, change them. And we'll just see how you guys do. All right. Wire is carrying a current that is traveling into the paper. Okay. In what direction does the magnetic field it produces act? Eric and Chase, what did you guys get? Good. So your thumb is the direction of the current. It's going into the paper. Your fingers wrap in the direction, so it wraps around clockwise. So this one will be clockwise. Good. All right. Ryan and Will, what about the next one? Going out of the paper.
Counterclockwise.
Counterclockwise. Good. So it's the exact opposite. Here it comes out, wraps around, counterclockwise. Okay, those ones are pretty easy. Here's one that's a little trickier. Two wires are traveling parallel to each other, both going into the paper. So here's the first wire, here's the second wire. Do they attract or repel one another? So they're both going to make magnetic fields, so they're going to do one or the other. Okay? So are they going to attract or repel? So I gave you a hint. Start by finding the direction of the field made by each and compare those directions between the wires. Then drawing a diagram might help. So this one is going clockwise around this way. This one is going clockwise around this way. Okay. I'll take a volunteer on this one. Anyone think they know this one? Why? What do you think?
Repel.
Why do you think they're going to repel?
He
just knows. Why just knows? He doesn't even need to think about, oh, Damon?
They will repel because they're going in the same direction.
So they're both clockwise. Okay? I want you to look at this, though. See how this is going up in between the two wires? See how this one's going down between the two wires? So even though they're both clockwise, what they're doing between is opposite. So it's going to attract. That's why I said look what's going in between them. So between them, they're going in opposite directions. So this is kind of a tricky question. It requires you to analyze the directions of the field. And I expected you to do what Damon did, which is they're both the same direction. They must both be the same. Well, they are the same, but not depending on where you look. So you got to figure out where you're looking, and that'll affect it. So they're going to attract. They're not going to repel. Okay, good. All right, a charged particle is traveling to the left through an upward magnetic field. In what direction will the magnetic force on the particle be? So the particle is going to the left. So the velocity is this way. There's a field that's up. Okay? In what direction will the force of the particle act? Lucian and Logan, what do you guys have? Okay. So we're going to the left. The field is up. I told you I wasn't going to do upfields, but I did do an upfield on this one. Okay, field is up. So it is going to be forward. You're correct. Yep, into the paper. So forward / into. Okay, next one. Wire current traveling out of the page. So current is going forward or out of us, towards us. Field is acting to the right. What direction would the magnetic force on the wire be? Okay, Caden and Gabe, what did you guys get for that one?
I said forward.
Forward, okay. So let's take a look at this one. So the current is coming towards us, so at your face. The field is going to the right. Okay? So the force is going to be up. Up for this one. In a second, I'm going to give you a really easy way to narrow it down to give you a 50-50 chance of getting it right. Okay? Narrow it down so you got a 50-50 chance. Okay, charged particle is going left through the magnetic field, but feels no force. In what direction does the magnetic field act? So charged particle is going left through a field, but it doesn't feel a force. There's no up force, down force, left force, right. There's no force. In what direction does the magnetic field have to be?
I said,
No.
there isn't one.
Nope, there is one.
There is one?
Mm-hmm. Nathan, any ideas? Nice.
Well.
Why left? Fogo?
Because if the particle feels no force, that means the magnetic field is working.
Yes. So the only way you have no force is if the field is in the same direction. It's the only way. Unless the particle isn't moving. But I told you it is moving. So if the particle's moving and there is a field, the only way there's no force is if they're in the same direction. Okay? Okay, let's do one more, and then I'm going to tell you how to narrow it down and give yourself a 50-50 chance if you're having trouble with this. All right, downward magnetic field causes a current-carrying wire to feel a force to the left. So the force is left, downward field. Braden and Sam, what do you guys think? What direction is the current going? Forward. Okay, let's look. So the force is left, so that's my thumb. The field is down, that's my middle finger. And the only way to do that is forward or into the page. Yes, you guys are right.
Yes. Yeah. No, that's all I was gonna miss. All right. I'll give them a big one.
Okay, here's how to make this easier for you. So if you're having trouble with this, which I know there's a lot of people that have trouble with this, here's how you make it easier. What do you notice about the directions when I drew them? Forward, left, down. Up, right, forward. Or sorry, backward, towards us. Forward, left, up. There's always three directions. There are always three. And it's always one forward or back, one up or down, one left or right. So if I get to a question like this one, and I knew the force was left and the field was down, there's only two options it can be. It can only be forward or backwards. Those are the only direction options. Okay? On this one over here, when I had to figure out what direction was the force, I had left motion, up field. So the only option left is forward or backwards. So it's a way to kind of make it a little easier for yourself. It makes it a little simpler because you can narrow it down to forward or backwards or up or down or left or right. And you'll know exactly, like it has to be one of these two. So that way you only have a 50% chance of getting it wrong instead of a 16% chance of getting it right. If you're guessing. Now, the best way to do it is to know what you're doing. Yes. The best way to do it is to know what you're actually doing. But if you're having trouble or you get stuck or it's confusing or you just blank on the test, then this is a good way to narrow it down for yourself. Okay? All right, last two here. North pole is inserted into the wire. What direction will the induced field be? And what direction will the induced current in the wire be? Okay, Ben and Mark, what did you guys get for A? What direction will the induced field be?
Away from the coil.
Yeah, so out, away would be fine. I would say out. But yes, if you said away, I'm okay with away. I know what that means. So I'm inserting the magnet into it, so it's getting more field in, which means it's going to push the field out. Okay? And Mark, what direction would the induced current in the wire be?
Okay.
So here's the loop of wire. It's going out. So think about some sort of loop. You can make one with your hand if you need to. Okay? So here's your loop. The field is going out, so stick your fingers out of the wire. And it's going to be counterclockwise. Counterclockwise.
And it's not even an answer.
Correct.
Oh, is that
Cool. So it's counter.
Counterclockwise.
Whoa.
Okay. South pole of a magnet is inserted to a coil wire. What direction is the induced magnetic field? So we're putting a south pole in, not a north pole in this time. Okay? Team Girl Squad, what'd you girls get for that one? Huh? In and clockwise. And so you got the exact opposite, which is exactly right. So south poles do the opposite of north poles. So if you insert a north pole in, it makes a field out counterclockwise current. So this would be the opposite of that. It would be in and a clockwise current. Okay? All right. Anyone have any more questions